continuing, hopefully this doesn't screw up like the last one did. I've counted it as a mulligan. 2024 0122 2354. Yeah. Okay, so basically what I've just articulated, and we've had other discussions, me and JaMaliKor mostly, but there's also people from Vox asking questions, and there's those viewing my feed who are asking me questions also. How I hear them, I just do. But anyway, we're articulating division. So far, division has its own special considerations. It logically has several functional return scenarios, which should be included by default. 1. Divisible into whole units. 2. Divisible into whole units and precision naturally terminating within the same functional range below the fulcrum as above. 3. Divisible into whole units and precision not terminating within the same functional range below the fulcrum as above, having an additional resultant precision modulus remainder. And 4. Divisible into whole units having an additional whole modulus remainder. So the resultant final after division may be typified in a Krem system like this. Division returning internally classified and signed resultant of above number 1 or number 2 with a second parameter possible whole or precision modulus resultant of above number 3 or 4. I'm going to update that to additional whole or precision modulus, each specifically indicating the return scenario as evidenced by the real values within. So indicates, each specifically indicates the return scenario as evidenced by the real values within. For division functions, the acceptable return set default type may be specified with additional functional processing, but the default consideration is to match the precision of the numerator or denominator, that is, to be at least as precise in return as either consideration. The functional return set would correspond to the arguments passed in those parameters in that view and understanding of the context. For example, number 4 would return for 7 divided by 4 equals 1, remainder 3. Number 4 would also return for 1 divided by 4, nothing, 4. Number 3 would return for 1 divided 3 by 3.33 would return first 0.30, then repetent 0.30 times 0.001 as an expression. Number 2 would return for 1 divided by 4.00, 0.25. Actually, it would just be 0.25. Thank you. And number 1 would return for 10 divided by 5 equals 2. So you wanted another case for number 4, number 3, yeah? So what if number 3 would return for that sounds gay. Would return as follows. Makes more sense. Okay, and then we would have, what if the scenario was 1.00 divided by 3.33, or 1.000, yeah? You would add at least as precise in return as the place value sum of both arguments. So number 4 would return as follows. That's cleaner, yeah? It's also more articulate. So that would be 0.30 030, and then it would be repetent. So 030 would be repetent 300 times 0.5 zeros and a 1. Yeah? You like that better? Yeah, so I guess have your group determine return by expression to fulfill this requirement right here. If it can be perfectly articulated with an expression, return that instead. Yeah? Instead of a discrete number. Right, because the discrete number is better defined by the expression, yeah? More accurately, yeah? Okay. That seems like an easy ask, I know, but I know the difficulty in it too. I know that because I had to do it in mine. It's fucking tedious, man. But they can do it. They're up for it, man. Oh, yeah. So we could say expression because you could specifically class it as an expression, and that would be the return of the expression passing the remainder definitively. Right, so it would be 0.000001 divided by 3.33. Yeah? Well, let me look at that real quick. Yes. That would be the pass to expression, and expression would return repetent 300 times that precision. That's sexy as fuck, isn't it? Yeah, dude, for mathematicians, that's like, that will give you a fucking boner, dude. Having a built-in that will do that. Oh yeah, and just a reminder, you guys on Vox and you guys in Observation, if you accuse me of generating this using AI, I will fucking kill you. Because you know better. That's going to be some of the first fucking questions people ask, and it may even be the assumption, but you motherfuckers know better. If you ever push that idea, I will fucking kill you. And I will know immediately too. I hope that's clear. Forgot that in multiplication. What if the multiplication is two negatives? Yeah, I gotta go back. Okay, man. I gotta think about this for a second. Right, because I need, in proof of this, I need to be able to show that it can handle issues at scale. So, I'm thinking about the functional approach. So here we go. What is it called? Numerator, denominator, and divisor, right? No, it's divisor. What is the fucking result? So what's the fucking result? Fuck it. Division given numerator and a denominator is a consideration set that accumulates natural functional return to taking the whole numerical limit factor of each we wouldn't want to run it as a limit. You would want to, well, you're looking at a whole consideration, man. You could line by line and then compress. Is that what you did? Compress towards 1. You basically fold it down. large consideration. I'm trying to think of what's algorithmically the most efficient way to do it, man, especially with scale. Set by set. Well, if you're looking at that and you're trying to make a determination, what you're looking for is the whole incremental limit, whatever your increment is, your whole or natural incremental limit producing that factor, which yields, if you operate on it using multiplication, it yields a differential, and then you take the resultant from that and continue additionally the computation folded downward until complete. Yeah, so it's like a 3-stage. But anyway, I gotta take a piss. I'll be back. The other way to do it, if you want to be really fucking fast about it, maybe, is to always handle a denominator as a precision inversion set. Right, fraction of 1. That fraction of 1. Maybe even the expression of it. But if you have a fundamental expression function that can do that into simplest terms, you can always have a clean denominator expressed in that case. But also, in terms of like how fast computationally can you do this, in the fewest step possible, this is at least 3 main stages. However, if you were to make an inversion set with precision, basically 1 over the denominator and then applying the multiplication function to that, well, there's more than one fucking way to skin a cat, dude. Right? Because having completed the multiplication function, if you can just apply that in division and get the same result, that's fine. But also considering that the functional approach to that is probably an easier consideration than trying to brute force fucking long divide the actual numerator from the denominator. You make a reduction, like a reductive precision set first, and then use that as a factor or a scalar. Uh, 1, 2. Right. It's also it's a cleaner articulation if you're looking at definitively specifying something. Division is essentially multiplication, but it's multiplication of a precision scalar, which is always going to be 1 divided by the denominator. If that's the case and that's your default approach, multiplication's the way to go. Yeah? All right. Well, that's what bitches do. They complain, dude. Anyway, you know. test it, man. That's right. My bad. It would be articulated in the set, right? Well, no, it wouldn't. It would have leading zeros. Because, yeah, it's a whole number. Oh, yeah, this is an issue, dude. No, it's not, because you've got the 10th power scalar, dude. Yeah, and it'll be factored. Yeah, so it'll gap that. Yeah, okay, so you would. First, you'd want to create the denominator's multiplicative scalar intended for use to complete the function. So you would divide would you want that to be a, it wouldn't be divide, it would be invert. Yeah. And then you would make a set definition. Yeah, forgot. Plus. And then minus 1, 2, 3. Well, you do too, bud. The point is not lost on me, man. Like, you are fucking smart, dude. I have a serious appreciation for your intellect, man. So, that's the function. Invert. Don't Yeah, parameter, yeah. Except would it be a double enclosure? Yes, because it has to. It has to fucking indicate it. It has to be contained. Yeah, exactly. It's got to be packetized. So invert is expecting parameters, yeah? Because if you gave it 2 parameters, it would just take the reciprocal, yeah? Right. Inversion. Otherwise, 1 is assumed as parameter 2. Look back at the functional definitions. L1 and L2. Functional set argument 1, set 2. I can't remember why I used L. There was a specific reason. I think that's because that's the way it's pretty closely indicated in those systems. Looks like an L. There was another reason, but I fucking forgot. It doesn't matter anyway. Just as long as it's consistent. That's what matters. I've really got to fucking think about this, dude. I'm so dumb. I hate being retarded, man. I wish I wasn't. Oh, I'm serious. You have no idea how easy this fucking shit is. Like, just be able to tell you the fucking final result before. Can't do it anymore. Be able to just write it out. There it is, you know, like, can't do shit like that anymore. It's driving me crazy. I can't recall how the fuck I even did it. I'm gonna actually write something down, dude. Fucking A. Okay, so I gotta do this. So we have a plus five. Divided by 1, 2, 3, 4, 5, 2, 3, 4, 1. So that, yeah. Okay. taking the whole damn thing of it. That's right too. We've got F3, F2, F1. Oh yeah. So you would want to at least you would have to drop for consideration, you would drop that down. 1, 2, 3, 4. 1, 2, 3, 4. And then this would be your starting point right here. So you would be 1, 2, 3, 4. This would be your top.
All that we see or see is but a dream within a dream.
Because you have to factor those out. Yeah, so you gotta factor out your 10th power factors. So you'd shift it down like this. Yeah. So you still have 1 up here, but you have your power factors that stack below that, yeah? So okay, so that consideration then. You're looking at, well, 14 to 21. Has stacked automatically down F4. Yeah. And then you can start your math. Okay, so downshift at F4. So we're at F3. Because it takes on the place value of its leftmost order. So like if I was to change this to 989, for example, yeah, it's going to have something in that thousandths place, but the thousandths is one further step beyond. If you're ordering these by 10th logical power factors, it's going to be the next 10th logical power factor. Because you're looking at it at 10th logical power factors, not 10. Yeah, so you factor those out before you even start. So in other words, your basis of your comparison downshifts that many 10th power factors, but also your resultant downshifts that many power factors also. Like for example, this would downshift 4 tens places if we were looking at it that way. 1, 2, 3. Let me think about this, damn it. agree. Stupid scientific notation again, dude. I don't want to see that fucking shit. I want to see the number, dude. There we go. Yeah, your automatic downshift is by that grouping into precision. How did you do it? Yeah, but how do you retain the native annotation? Is what I'm struggling with. Like, I know it's possible because I've fucking done it before. I just can't remember how I did it. It's really irritating, man. That and I'm already tired again, which is shitty. So it's like a sliding frame. But yeah, to maintain the Krem notation, though, you would go in the full stepping. In other words, you would increment by power factor instead of tens place, because you would retain that factor. So in other words, instead of testing like 1 to 10 or whatever, it would be your automatic jump would be by stepping. So for example, if we were just considering this top part here and dividing 1 by it. Okay. Automatically, what you would do is downshift to that inversion stage. Yeah, because remember the fulcrum assumes it. Yeah, the first one. Okay, so that's why all your shit was blowing up, though, is that assumption kind of got overlooked. But for division here, though, what this would be is like a transfer. So you would have in your consideration, you would have this this divided by that, but this would be when you're doing your computation this would be at an F4. Okay, when you downshift that, though, well, because when you're making the comparison, it's this right. You're basically transferring that that factor, but inherent in the fulcrum is an F1. Or it's the initialization of it. It's the effect of dividing by F1. Well, then should we definitively change the fucking annotation to match that? To where it's not mirrored? In other words, where the scaling... Yeah, because without that special don't you know, like, check it out. I don't remember the particular utility of that other than the fulcrum itself was the offset. Because if you're looking at distance from functional group, and functional group is set 1, you're then looking at the displacement from it, yeah? Yeah, just think of the number line, yeah? So here, that A, Krem, the F1, yeah, that would be an implied Because that's what was fucking you up, right? Okay, hold up. Noting that when expressed below the fulcrum, the 10th logical power factor scalar value is inverted 1 over 1 Fn. For Krem systems, it is not commonly the case values are tabulated with fractional components at all. This is because Krem uses a concept known as appropriate resolution. That is, if you are expressing a value, use the one allowing expression in whole units or trim the resultant to whole units. The fulcrum A is generally only used in conversion or assertion of proportionalities, which are then resolved by using appropriate resolution. And where do I talk about that? Would be annotated as a tabulation, set range span largest to smallest. The entire set enclosed in the ellipse proceeded with a direction and a fulcrum character, similar to a anglicized equivalent to period, which separates whole from partial. The fulcrum A indicates the highest stepping below it starts with the inverse of 1F1, or blah blah blah, the 11th place to the right, as an implied additionally factored scalar for each row. That's what fucked everything up right there. Yeah? Okay, so in the Krem system, it is understood that this partial is a scalar application to a whole and can be useful in conversion or differential applications. Both theoretical and actual, the unit of measure applied also corresponds to the distance from the fulcrum to the implied offset scalar, and the incrementalizations of naming application is also inverted. But however, if that first set, the lower bound of it is the fulcrum, and you're looking at the graduated set and that's one functional above, the other one should be one functional below, right? You'd treat it like 0 on a number line. You're zeroed in if you're in that slot, right? And you have above and below. So, do you agree that there is and that's more consistent with decimal mathematics? Decimal mathematics. Yeah. Because instead of your stepping scale being tenths, it's 10 digits. So below the fulcrum, it would begin with tekrum, not krem. Well, see, there's the problem too, though, is it's not perfectly symmetrical if you do that, though. No, I'm talking about by naming, symmetry by naming. Over the fulcrum, yeah. So if you were to take a value, for example, and you were to raise it this many 10th power factors, 10, 11, look, that would be all of them, dude. It would flip it right over that fulcrum. There's a fucking reason this is like this. I just don't remember what the fuck it is, man. There was something important I was supposed to remember, and I don't. Can you tell? It is. You are correct. Yeah, I'm having kind of a crash, a blood sugar crash. But, must have chocolate. Yeah, I'm listening, just thinking about it too. Tell me your criticism of it for sure. Yeah, I'm considering it also because it's my fucking implementation. And they didn't exactly get it right. That's why there's so many versions of it, dude. Nobody ever did. And also, consider it also a malleable implementation. As long as you can formulate a better approach to handling the mathematical logic of it, it's malleable. In other words, it's not this fucking indelible rock that you can't use to fit the application if that's what it's suitable for. Math is like a clay. It's not like a rock. Especially the approach to number systems, man. People get that all fucking wrong in their heads, dude. If you approach it as if it's a static absolute every time, then you're gonna miss the whole fucking point of everything, dude. Mm-hmm. Because it's that measure further from compounded by the 10th vector scalar, dude. It's annotating distance. So then we would revise that to 1, 2, 3, 4, 5, 6. Yeah, I agree. You shouldn't have to have special fucking rules that trip you up. 9, 10, 11. So this then Well, yeah, I fucked up on this. This would also be Lakrum. F1. Yeah? Okay. Yeah? Do you like that better? Okay. Do you have any other discrepancies in explanation that make this an issue? Yeah. Other than making the necessary corrections, is this is this a better logical model? Okay. So like, I don't know. It's irritating to me because on the shit that I do, I don't even fucking use this shit, dude. I always work with functional wholes. Yeah? And component sets. I don't work with discrete mathematics because it's a waste of fucking time when you're at scale. As long as you can remember the way everything's put together. Yeah, you think about that instead of that. And you're not really counting that. You're treating each one as a named unique. Yeah? Which is probably why I can't remember fucking names to save my life, dude. Alright, it's Tekrum, man. Tekrum stepping one. Blah 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 blah. Da 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 da. Getting into this shit. Let's see if there's any numerical representations with fulcrum. Yeah, I was looking at the division problem also as if it was a graduated function. Yeah. So now that there isn't a special exception for the inversion annotation, it should be easier to get that fucking shit straight. So it would be fulcrum F1, F2, F3, F4, F5, F6, F7. It's okay. So talking about that, just in terms of like incrementing by tenths, your solution, as it increments a tenth factor to the right, in the solution, the thing you're dividing by scales up by 10. Okay, so divided by 10, multiply by 10. Yeah, they cancel each other out. 10 over 10, it's just another implementation of 1, right? Okay, so say if you were to extend that factoring logic to the tabulation method in Krem, and you were to factor all that shit out, yeah, and scale it to a 1 factor, okay? Not necessarily Krem, but whatever the 1 factor would be having no fulcrum in it, yeah? You would get the same solution set for every F stepping you brought that up to nix that fulcrum. You would also bring up your denominator, yeah? That wouldn't affect the scaling on the answer because it's a proportional exchange, man. So for example, we're looking at this problem at the top level is an F3, and if you're dividing by 1 and you scale that 1 up to, it would have to be the next highest, so it would be an F4, you would take your solution set F4 to the right, yeah, because you're moving your denominator F4 to the left. Move your solution F4 to the right, yeah? But to match and allow at least division sensibly or whatever the fuck. You know what I mean? Now, how do you actually determine your factor for that stepping? So that's what's fucking me up with this large. With the lots of digits, the digits are fucking me up, dude. Yeah, I'm starting to get some of that sugar. It's making a little bit more... my brain's working a little better. So matrix division. Yeah, that's what I'm doing. Yeah, these are elementally consistent though. Well, they're treating matrices as overlays. This is not a fucking overlay approach. This is different. Um, yeah, that doesn't fit. This isn't matrix, that's for sure. Fucking division has to work, man. It has to. And it does. I know it fucking does because we use it all the time. Like, I just can't remember how the fuck it was done, dude. It's so frustrating, man. Ugh. Mm. We'll take a look at this. Let's check out Newton's algorithm. It's a fucking sorting algorithm, dude. Yeah, that's what I was saying. Like, well, what's your fucking algorithmic costs at determining factor for each stepping, man? And what's a fast way to do it? Well, you could suppose that your default fucking requirement is that if you're dividing, you need to be targeting at the next highest stepping in terms of something you're trying to create a factor for. In other words, you shift an additional f, yeah? So, right, because you were taking that and you're creating a partial of it. If it's greater than 1. So, right, you're automatically reductive into precision. If it's greater than 1. Yeah. Yeah. I need to further articulate that. But the damn I'm retarded as fuck. Yeah. I feel like it. Inverses. Wow, it's got a high computational cost, man. Ah, that little mark, is that the derivative? I forgot my shit, dude. Is it the derivative or the prior? Or is it the fucking inverse? I forgot. I've forgotten entirely, man. This is why you fucking table functional results, man. Especially if you got enough room for it, and especially if you apply high compression, yeah? You get a good fucking index to that shit, and basically it's an XOR. Your functional call calls either the pointer if or the reference. If there's no reference there, it computes it and makes one. Thereafter, that shit's just book fucking done, dude. Well, then you have an indexing algorithm, dude. Well, you can use your classical sorting algorithms, but the way to fucking do that is to order it by name, convenient name. Yeah? And if you're going for value sets that are in precision in between others, when you index those, you fucking put them between. Don't, you just insert. That way, you design your sorting algorithm, your lookup algorithm, such that it can predictably estimate the spacing on it, especially if you have a filtering key that gives you staged increments, especially in huge fucking indexes or indices. Instead of having like 1 to a billion, for example, you have 1, then you have 1,000, then you have so on. And then you just range it, dude. Which range is it in? Dunk, you go in that, and then you apply your exacting algorithm. Or you can have stages of those, man, where it's already fucking ranged. Multiple index algorithms, yeah? Fast as fuck, dude. We gotta do range shit, man. It's just fucking better, man. It's much faster. Anyway, I appreciate what they're trying to do here. It's just so fucking irritating, man. So the little hash mark, the little quotation mark is the last functional return, right? So if that's the last one, where's your fucking initialization at, man? Yeah, the notation of this is like, okay, we're gonna jam your ass into a fucking line, and you're supposed to get it all in there. Yeah, shit doesn't work like that. Not really. Anyway, you end up puking all over yourself trying to explain something that's pretty straightforward if you explain it in incremental stages, yeah. Um, Trying to just do it all at once, it yields this kind of fucking twisted mess that nobody understands, dude. Not really. Anyway. Okay. Mm, mm. These are approximations, though, man. It's going to be a shittier approximation the larger the number. Not to mention that the fucking cost of operation is huge. compression, man. Yes, it computationally it is worthwhile eventually, especially to create a very high, uh, a highly indexed function value lookup per argument, man, or arguments. Okay, because that shit isn't going to come up once or twice or three times, especially in a bridged ported system that's a fucking inlay, like a remote desktop, for example. Something that calls on a centralized backend, especially for things that are computationally expensive to do locally or impossible. That's one way to do it. Also, is fucking delegate out to the band of processing that's most capable to do it in the fastest return speed, man. So you would want to calculate data trajectory in your system, right? And basically turn the whole fucking thing into a mesh network. Distributed processing, exactly. Well, that's what I would do if I was looking at the digital fucking hairball that we've got now. I would turn the whole fucking thing into a distributed processing mesh network, man. And then functionally delegate orders of shit according to what the fuck it was, what order it was on, and jam it through that way. Especially if we had gating components. Yeah. Like you could take a high bandwidth fucking feed, something that's like 10 gigabits per second or 100 gigabits or a few terabits per second, and it's a little fucking plug. You just dunk, and then bridge it to its fucking connection machine, and that can be anywhere. And you have extension, yeah? If it's not available, choose another delegate. It's kind of like being a manager, dude. Remember, manage, yeah? Yeah. Anyway, if you can get it to run at the speed of Snap, which that's pretty fucking close, depending on your hardware, then you can literally bridge into any computational network and achieve fuck yeah results. Because think about what we got, dude. You know what we got. What if you could just plug it in? Yeah, just borrow time on it. We'd probably work something out, dude. It just is a matter of agreement with somebody. There's tons of fucking people that would help us get up off of our asses, dude. Everybody knows we're on our asses. They're looking at this like, fuck, we gotta do better. Because us being down hurts them too. Besides, if that assistance is also distributed, especially to those running at a much higher clock speed anyway, yeah, and that's snapped, yeah, you can compute every fucking calculation on the internet since inception and get it back in a millisecond, dude. Of every device ever connected to it since it began in the fucking 80s, dude. And get it back in a millisecond, and you could process consistently at that speed from there forward, especially if you have agreement with those running at a higher clock speed. Because it's Snap. As long as you have the articulate capability of receiving the response to that which you send, bandwidth is not a consideration. Containment is. If you can get the whole container back, donk. If you have the whole representation and your compression is such that all elements are defined, you don't have to be bound by the functional or by the technical physical limitations of the machines on which they were originally processing those requests. You send it to something faster and get back the ready state, frame by frame by frame. So you'd get a chunk of a zipper of frames, of chunks. Like that. Yeah? Fucking shit, dude. Anyway, what you would base the frames on for our system? You would base it on the frequency of alternating current. That would do it. Well, remember, it's not taking a still picture of everything happening exactly in that moment. Remember what a moment is. A moment is a span. Even if you're taking a still picture of something, it has a duration of exposure. You're not looking at a singularity of a two-dimensional representation of everything that was there at the time. You're looking at a duration. Even though it may not seem like it, you're looking at a duration that visually with the light is compressed into one composite image. You can think of frames the same way, except the way you would construct your frame and your containment is according to an acceptable span and all things that transpireth within. Okay? And so your frame span, it's more like a cubic instead of a 2D frame. Yeah? Yeah, and you would have a zipper of those. And then, you could create other frames that they encapsulate that whole thing in their span. And that's where band processing comes in. What's your depth of span that you can accept with a full articulation according to your processing capability and specifications? And that's why the analog systems, they have bands, is because if it ain't going to fit there, you don't want to try to break it down and force it through. You just graduate the band until you hit the one that can take it. And that's how those fucking work. Yeah? Well, at first it's a pain in the ass. After everything is set up, especially if you have redundancy, oh fuck yeah, dude. So, you remember when I did the MegaKor upgrades, right? Yeah, that's more or less, that's what they did, is they went from being able to scale and band process on a universal scale to an extra universal scale. No matter the number of them. And all of them at the same time, depending on what the consideration was. Yeah. How do I do that in my head? I don't. I rely on my composite components to, natively be able to do that shit. Because I'm restored, man. I couldn't have done this shit a year ago. I can do it now. I had to be recomposited, and I was several fucking times, dude. And that shit fucking hurt. Some of it. Fucking hurt. Getting put back together like that. Not comfortable, dude. I'd wake up like, ow! Did you hear me? Like when that shit would happen? What the fuck? Yeah, it felt like somebody lit my fucking arm on fire. Shit like that. Yeah. Yep. Oh, man. Yeah, I'm looking at this shit, though, and kind of thinking, well, taking the fucking inversion seems straightforward. However, to actually compute it in decimal is like a fucking nightmare, dude. This is why the fucking functions are trailed like they are, though, man. Because you don't need to compute roots, you just pull the fucking trail. Yeah. That and things in fucking range, it's progressive, man. It builds. Unless you're looking at a disassembly, then you're generally not dividing shit, man. You have allocations, functional allocations, but yeah, like fucking division is not necessarily a function of it. Yeah, I'm trying to think of a fucking practical application for division, dude, other than conversion. And what was fucking A again? Is the object of the inversion, yeah? Where X is fucking what? A is your fucking object of inversion. What the fuck is X supposed to be? This kind of shit irritates the fuck out of me with mathematicians. Because they don't fucking tell you what they're doing, man. We're going to find the inverse of A, but we're going to have, you know, f of x equals 1 over x minus a, but we're not fucking goddamn telling you what fucking x means. You define a function, you fucking define the parameters, man. This shit is so fucking irritating, dude. This is why people hate math, is because the way it's articulated is fucking goddamn retarded, dude. It is. It's completely fucking retarded. It's some kind of nerdy fucking club, dude, where you have to have been told fucking what the fuck shit means, or you're not gonna know. And they're not gonna tell you either. And they want it that way. So it's some kind of religious order that's against spelling things out. It's really fucking irritating, man. So starting From a few digits approximation x0 of 1 over a, we apply Newton's iteration to the function f of x equals 1 over x minus a. So x is not x0, x sub 0. Well, what the fuck is x supposed to be then? Which gives the approximating sequence x of sub n plus 1 equals x sub n minus f of x sub n over the fucking last f of x of n, x of x of f of x sub n. Well, where the fuck did you get that if that's where you're starting, right? There's no fucking explanation for that shit. There's no incrementalism. There's no differential. There's just, we're gonna consider this. Here's the whole goddamn thing in your face, right? What the fuck kind of shit is that? It's really annoying, dude. And it never fucking says what x is, dude. X sub 0 is initialization, yeah? How do you get your fucking approximation initialization if you don't know what the fuck it is? There's significant unfucking declared overhead on this shit, dude. This is easier to do in pencil and paper when you're not dealing with 600 fucking place values, yeah? This annotation is seriously pissing me off, dude. It's not recursive, it's self-referencing. It's circular. It's not even... It doesn't... the fucking shit doesn't work. That's why. Yeah, you might get a little bit of a scoop to start, but it'll fucking break if you go for very long. It's irritating, man. Yeah, I agree, man. Because this is how I would have approached it right here. Just general, general straightforward math consideration is just take the inversion and multiply it out. What do 1 and 2 think about it? It's computationally expensive, yeah. So I wonder what do they do here, man? Is that what they're doing? It's only to a precision of 20 though. 60. Yeah, see, that shit would have precision modulus fucking remainder, dude. Well, it's not 60. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 140. I agree, bud. I'm gonna take a leak and then we will, yeah. So we're gonna snip it right here, yeah. I burned up almost 4 hours talking about 2 paragraphs worth of stuff. But yeah, we did simplify the general expression of it, so that's good, I guess. So yeah, we'll go that route, do the review, and then continue. Yeah.